Let's solve 18 problems on limits at removable discontinuities. Okay, the first one, limit as x approaches 2 of minus x minus 2 by x square minus 3x plus 2. Now, here, if we do direct substitution, what happens? We get 2 square 4 minus 6. 4 minus 6 is minus 2, minus 2 plus 2 is 0. So in the denominator, you will end up with 0, which is not acceptable. So let's see whether we can do something by factoring the denominator. Minus x minus 2 by, and let's factor this x, uh, 2 ones 2. So minus 2 minus 1. Does this come correctly? Add up these two. Minus 2 minus 1 is minus 3. Minus 2 times minus 1 is 2. Okay, and here if you notice, these two cancel out, and we are left with limit as x approaches to of minus 1 by x minus 1. Now we can do direct substitution. So this would be equal to minus 1 by 2 minus 1, which is equal to minus 1 by 1, which is minus 1. Okay, so that is the first problem. Now let's look at the second problem. Limit as x approaches minus 2 of minus x square plus 5x plus 6 divided by x plus 2. Again, if we do direct substitution, minus 2 plus 2, 0 in the denominator. So let's factorize the numerator, and minus we can take it out. So minus limit as x approaches minus 2 of, let's factorize this x. Now this comes to 3, 2, all are positive, so plus 3 plus 2 is 5, 3 times 2 is 6, divided by x plus. So these two cancel out, and we are left with minus limit as x approaches minus 2 of x plus 3, and now we can directly substitute. So minus 2 plus 3, which is equal to minus 1. A third one, limit as x approaches minus 3 of x plus 3 by x square plus 5x plus 6. Now remember, in the numerator, even if it is 0, no issues. In the denominator, it should not be 0. So let's do this. Minus 3 square is 9 plus or minus 15. So 9 minus 15 is minus 6 plus 6 is 0. So denominator becomes 0 by direct substitution. So let's simplify this. Limit as x approaches minus 3 of x plus 3 by, again we factorize the denominator x and 3 times 2, okay, and now x plus 3 cancels, and we can write this as x approaches minus 3 of 1 by x plus 2. And now we can do substitution. 1 by minus 3 plus 2 is equal to 1 by minus 1, which is minus 1. Okay, fourth one. Limit as x approaches 1 of minus x square plus 3x minus 4 by x minus 1. Again, denominator becomes 0. So let's simplify this. Take minus out. X approaches 1 of x, and this becomes 4 ones 4. So 4 1, this is positive, so this will be positive and this will be negative, divided by x minus 1. So this cancels out, and we are left with limit as x approaches 1 of x plus 4. we can do direct substitution. So this becomes minus 1 plus 4, which is equal to minus 5. Okay. Now let's look at the fifth problem. Limit as x approaches minus 2 of x plus 2 by x square minus 4. Okay, again minus 2 square is 4, 4 minus 4 is 0. So we need to simplify this. So let's take limit as x approaches minus 2 of x plus 2 by, now a square minus b square is a plus b times a minus b. So x minus 2 times x plus 2. So x plus 2 cancels. Limit as x approaches minus 2 of 1 by x minus 2. And now we can do direct substitution. So this would be equal to 1 by minus 2 minus 2, which is equal to 1 by minus 4, which is minus 1 by 4. Okay, sixth one. Limit as x approaches minus 2 of x plus 2 by x square plus x minus 2. Again, denominator minus 2 square is 4. 4 minus 2 minus 2. That is 4 minus 4 is 0. So again, we need to simplify. So x approaches minus 2 of x plus 2 by x. So plus 2 minus 1. This cancels and we have limit as x approaches minus 2 of 1 by x minus 1. Now we do direct substitution. So 1 by minus 2 minus 1, which is equal to 1 by minus 3, which is minus 1 by 3. Okay, now let's change gears a little bit. So seventh one, limit as x approaches 2 of square root of x minus 1 minus 1 by x minus 2. And again, 2 minus 2 becomes 0. So we need to do something. So what can we do? Let's rationalize the numerator and see what happens. So limit as x approaches 2 of square root of x minus 1 minus 1 by x minus 2 times square root of x minus 1 plus 1 by square root of x minus 1 plus 1. This is the entire thing. Okay, so limit as x approaches 2 of, now this will become what? X minus 1 minus 1. A minus b times a plus b is equal to a square minus b square by x minus 2 times square root of x minus 1 plus 1. Okay, now this becomes limit as x approaches 2 of x minus 2 by x minus 2 times square root of x minus 1 plus 1. X minus 2 cancels out and we have as x approaches 2 of 1 by square root of x minus 1 plus 1. And now we do the substitution. 1 by square root of 2 minus 1 plus 1, which is equal to 1 by square root of 1 plus 1, which is 1 by 1 plus 1, which is equal to 1 by 2. Let's do the eighth one. Limit as x approaches 0 of x by 1 by minus 2 plus x plus half. So again, let's see, if this becomes 0, it becomes minus half plus half. So it will be 0. So we can't have that. So let's simplify as x approaches 0 of x by 2 minus 2 plus x by 2 times minus 2 plus x. Okay, so limit as x approaches 0 of x by, this becomes 2 minus 2 0 plus x. So x by minus 4 plus 2x. And what we can do is we can write it as limit as x approaches 0 of x times minus 4 plus 2x by x. These two cancels out. And we can do direct substitution. So minus 4 plus 2 times 0, which is minus 4. Let's do the ninth one. So limit as x approaches 1 of square root of x minus 1 by x minus 1. Again, 1 minus 1, 0 in the denominator. So let's rationalize the numerator. So limit as x approaches 1 of square root of x minus 1 by x minus 1 times square root of x plus 1 by square root of x plus 1. Okay, so what does this become? This becomes limit as x approaches 1 of x minus 1 by x minus 1 times square root of x plus 1. X minus 1 cancels, and now we can do the direct substitution. So it becomes 1 by square root of 1 plus 1, which is 1 by 1 plus 1, which is 1 by 2. Okay, 10th one. Limit as x approaches 4 of x minus 4 by square root of x minus 2. Okay, again we can rationalize. So let's rationalize the denominator. So square root of x plus 2 by square root of x plus 2, which gives us limit as x approaches 4 of x minus 4 times square root of x plus 2 by this becomes square root of x square becomes x minus 2 square, and this is x minus 4. X minus 4 cancels out, and we are left with square root of x plus 2, and we can use direct substitution. So this becomes square root of 4 plus 2, which is 2 plus 2, which is 4. Let's do the 11th one. Limit as x approaches 2 of square root of x plus 2 minus by x minus. Okay, again, let's rationalize this, the numerator. So square root of x plus 2 by square root of x plus 2 plus 2. So what do we get? We get limit as x approaches 2 of x plus 2 minus 4 by x minus 2 times square root of x plus 2 plus 2. This plus 2 minus 4 becomes minus 2. So x minus 2 and x minus 2 cancels out. So we are left with limit as x approaches 2 of 1 by square root of x plus 2 plus 2. And we do direct substitution. So square root of 2 plus 2 plus 2, which is equal to 1 by square root of 4, which is 2 plus 2, which is 1 by 12th one. Limit as x approaches 1 of x minus 1 by square root of x minus 1. Square root of 1 is 1, 1 minus 1 is 0. So we need to do something. So limit as x approaches 1 of x minus 1 by square root of x minus 1 times rationalizing the denominator plus 1 by square root of x plus 1. Okay, so this becomes limit as x approaches 1 of x minus 1 square root of x plus 1 by x minus 1. These two cancel out, and we can directly substitute. So square root of 1 plus 1, which is 1 plus 1, which is 2. Okay, now again let's change gears. So 13th, limit as x approaches 0 of sine x by x. Now, this is a very important limit. Okay. And we can prove this in multiple ways. The straightforward way is by actually taking values. So let us say x is, okay, start with 0, right? And we take 0 0.1, 0 0.02, 0 0.003. Then what happens to sine x? Now sine 0 is 0. Sine of 0.1 is 0 0.1. Sine of 0.02 is 0.02, 0.003. So as we keep going forward, you will realize that x is equal to sine of x near 0, not throughout, very close to 0. So here it will be a little bit of approximation. This will be approximation. So as we keep getting closer and closer to 0, as x gets closer and closer to 0, sin x will be equal to x. Here, of course, it looks like it is equal, but I have stopped at, so many decimal places. It's like, okay, so which means what? This would be equal to limit as x approaches 0 of, now instead of saying sin x, because they are equal, I can say x by x, which is equal to, and these two cancel out, and we are left with 1, which is a constant, so I can say 1 the limit. There are other ways to, prove this much more uh, mathematically rather than looking up sign tables. Okay, so that is the 13th one. Let's look at the 14th one. Limit as x approaches 0 of sine 5x by x. Here we have already seen that as we get closer and closer to 0, sin x is equal to x, right? So this can be written as limit as x approaches 0 of sine of x is equal to x. So which means that limit as x approaches 0 of sine of 5x would be equal to 5x, right? Okay, keep this in mind. So what we can do is this, we can write it as limit as x approaches 0 of sine 5x. This sine 5x can be replaced with 5x by x. So these two cancels out, which means this is going to be 5. 15th one. Limit as x approaches 0 of sine square 5x by 4x square. Now, once you know this, then these things are just a little bit based on the same thing. It is based on the same thing, but you need to arrive at it a little bit differently. So this we can write it as limit as x approaches 0 of sine of 5x square by 4x would be equal to limit as x approaches 0 of sine 5x can be written as 5x square by 4x square, which is equal to limit as x approaches 0 of 25x square by 4x square. X square gets cancelled, and now we end up with 25 by 4, which is a constant. So the limit is 25 by 4. Okay, now let's look at the 16th one. Limit as x approaches 0 of tan 3x by 3x. Okay, now immediately you can see the pattern as x approaches 0 of sine 3x by cos 3x times 3x, right? And remember, limit as x approaches 0 of sine x by x equal to 1. So here sine 3x by 3x is 1. So limit as x approaches 0 of, we can write it like this, cos 3x times limit as x approaches 0 of sine 3x by 3x. Now here we can do direct substitution. Cos 3 times 0 times this is 1. So this would be 1 by cos 0, which is equal to 1 by 1, which is 1. Okay, let's do the next one. 17th one. Limit as x approaches 0 of 1 minus cos x by x. Again, denominator 0. So let's rationalize this. Limit as x approaches 0 of 1 minus cos x by x times 1 plus cos x by 1 plus cos x, okay, which is equal to limit as x approaches 0 of, this becomes what, 1 minus cos square x by x times 1 plus cos x. Okay, now 1 minus cos square x is, remember, sine square x plus cos square x equal to 1. So 1 minus is sine square x by x times 1 plus cos x. Okay, now this we can split it. So we can say limit as x approaches 0 of sine x by x times limit as x approaches 0 of sine x by 1 plus cos x. Now this we know becomes 1 time, and this becomes sine 0 is 0, 1 plus 1. So here 0 by 1 plus 1. So overall 0. The important point here is that the denominator should not be 0. Okay. 18th one. Limit as x approaches 0 of sine x by sine 2x. Again, pretty straightforward. We can write it as limit as x approaches 0 of sine x by 2 sine x cos x. You have to remember these identity. So sine x gets cancelled. And now we can do direct substitution. 1 by 2 times cos 0, which is 1 by 2 times 1, which is 1 by 2. Now this can be done in a different way also. So we know limit as x approaches 0 of sine x times limit of x approaching 0 of 1 by sine 2x. Now this would be x times limit as x approaches 0 of 1 by sine 2x. But we know that limit as x approaches 0 of sine 2x is 2x. So this will be 1 by 2x. So x cancels and we are left with 1 by 2. Two different ways we can do this. That's it. Bye.